teacher. Welcome to our science class. How are you today? I know you are doing right because you've just come out with your air-conditioned room, having breakfast with coffee. Your juices are ready for your snack, and your mother is just come out from your house and walking under the sun to buy your lunch. Okay, class, these are some of scenarios that will lead us to identify our topic for today. Do you have any idea about the lessons for today? Yes, I heard it. Yes, heat and temperature. Heat and temperature the same or are they different? Okay, but before anything else, let us know the objective of our lesson. For number one objective, distinguish heat between temperature. For number two, explain how heat and temperature are related. And for our milks, differentiate heat and temperature at the molecular level. Okay, let us first define what is heat. Heat is the transfer of energy between objects or places because of difference in temperature. Okay, heat is a form of energy and it is measured in joule. The instrument used in getting the heat is called calorimeter. And that energy is a thermal energy. It is actually contained in an object due to motion of particles. Matter contains thermal energy. Heat thermal energy in transit. After heat has been transferred to an object, it ceases to be heat and becomes thermal energy. Therefore, heat can also be defined as the amount of thermal energy that is added to or removed from a system. Kinetic theory of matter. All the particles that make up matter are constantly in motion. In solid, vibrating atoms. In liquid, flowing atoms. And in gas, atoms that move freely. In kinetic theory of matter, it explained that matter is made up of tiny particles, that particles of matter are keep moving all the time. The kinetic energy of the particle in the system added together, as opposed to temperature, which was measure of the average kinetic energy of an atom or molecules in the system. Upon collision, the particles of body with higher temperature transfer energy with the particles of body with lower temperature. The transfer of heat will always alter the temperature of the object. Let us now define temperature. It is a measure of how hot or cold an object. Measurement of average kinetic energy of all particles in an object. There are three units in measuring temperature. First, degree Celsius. Second, Kelvin. And then third, Fahrenheit. Fahrenheit, water freezes 32 degrees Fahrenheit and boils at 212 Fahrenheit. Celsius, water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. Since the Celsius and Fahrenheit scales can go below their zero mark, they have negative values. This is why they are reported in degrees. Since Kelvin is started at 0 and cannot go below that absolute 0, then you cannot have negative Kelvin. This is why Kelvin is not reported in degrees. Kelvin is always positive. The size of the Fahrenheit degree is smaller than the Celsius degree. The difference between the boiling point and the freezing point is 180 degrees. Not 100 like Celsius or Kelvin. The 0 points are all different on all three scales. Temperature depends on particle movement. All matter is made up of particles that are moving. Even solid objects have particles that are vibrating. The motion from the particles gives the object energy. warmer a liquid is, the more the particles move and thus the liquid expands, or takes up more spaces, and rises up through the tube. As the particles move, they will impart some of their energy to other particles through collisions, and this will continue to occur until the whole system is at the same temperature in a state called thermal equilibrium. Thermal equilibrium, the condition under which two substances in physical contact with each other exchange no heat energy. What about the relationship between heat and temperature? If something gains heat, again it becomes hotter. Particles move more and more. If something loses heat, it becomes colder. Particles move less. And now let us determine the relationship between the heat, temperature, and kinetic energy. If heat is added to an object, the particle of it gains kinetic energy, and it will move faster, which would cause the temperature to increase. On the other hand, if heat is removed to an object, the particles of it loses energy or kinetic energy, and it will move slower, which would cause the temperature to decrease. And when heat is not present from a body and each environment have reached thermal equilibrium. Now class, let us have a very short activities that will show the relationship between heat and temperature. These are the different materials we are going to use in these very short activities. Number 1, you have wire gauge. You have number 2, tripod. Number 3, alcohol lamp. Number 4, you have beakers. You have thermometer. And the last one, you have here the ice. Okay, for setup number 1, what will happen to a water when you put it over the flame? Okay, this is for setup number 1. The initial temperature of water is 31 degrees Celsius. So let us observe setup number 1. The water is boiling. It absorbs the heat from the flame. The kinetic energy of molecules of water move faster. What about for temperature? Let us see the temperature of this water over the flame. So the first reading for this final temperature will be 70 degrees Celsius. So it means water temperature rises or it becomes hot. So repeat, when we put the water over the flame, the water is boiling because it absorbs the heat from the flame. The kinetic energy of molecule of water move faster. And the temperature rises, become hot. Okay, let us now perform the setup letter D. What will happen to water when placed inside the freezer? So the initial temperature of tap water or drinking water is 31 degrees Celsius. Assuming that we will going to place it inside the freezer. So this is now the water that we place inside the freezer. Let us now observe. After putting water inside the freezer, it will become an ice. So definitely it releases heat. And the kinetic energy of molecule of water move slower. What about the temperature? Let us see. Okay, in a short time, we notice the temperature drop. It becomes 18 degrees Celsius. The water becomes cold. After putting the water inside the freezer, it will be frost and it become an ice because it releases heat. And the kinetic energy of molecule of water move slower. The temperature drops and become cold. It transfers from an object of higher temperature to an object of lower temperature. Okay, that's all for today. Goodbye, class. Have a good day. God bless.